the eye of Super Typhoon Bavi glowed in moonlight as it closed on Guam and the northern Mariana Islands. Around it, a nearly perfect ring of clouds spun over water warm enough to keep feeding the storm. Less than 2 days earlier, Bavi had been a tropical storm. By the time the islands entered its warning zone, it had exploded into a Category 5 system with winds near 108 miles per hour, and it was the third tropical cyclone of 2026 to reach Category 5 intensity. That number made Bavi part of a remarkable year, but it does not explain what the people of the Marianas actually experienced. The center did not cross directly over the island of Guam. It passed across Rota, north of Guam, while Bavi's enormous wind field, rain bands, seas, and storm surge spread danger across the wider island chain. Guam was struck hard without taking the eye, and that distinction is the first key to this storm. A tropical cyclone is not a dot moving along a line. The line marks the center, but the hazard extends outward through rotating bands of wind and rain that can cover hundreds of miles. One island can enter the eye wall, while another, farther south, suffers flooding, power failures, blocked roads, damaged utilities, and dangerous coastal conditions. The exact track determines who receives the most violent core, but it does not draw a clean boundary between destruction and safety. Bavi reached the region during the first week of July. On July 4th, the National Weather Service in Guam described it as a very dangerous Category 5 super typhoon moving toward the Marianas. Typhoon watches became warnings as Guam, Rota, Tinian, and Saipan moved through escalating readiness conditions. Ports began restricting traffic, emergency shelters opened, and residents were told to finish preparations before damaging winds arrived. And if you value evidence-led documentaries about major changes across Earth, subscribe and stay with this channel. We follow the measurements, the warnings, and the physical mechanisms without turning uncertainty into a prediction. And then, the storm intensified again, and satellite and operational analyses show Bavi's winds rising from about 60 miles per hour on July 2nd to roughly 160 miles per hour by July 3rd. It had crossed the threshold from tropical storm to super typhoon in little more than a day. After a brief weakening associated with an eye wall replacement cycle, it strengthened once more and reached an estimated peak near 108 miles per hour as it approached Rota. This was not slow development that gave the islands a week to watch a distant spiral gradually become dangerous. The storm's core reorganized rapidly over the western Pacific, turning a developing cyclone into one of the strongest classes of storms on Earth while it was already moving toward inhabited islands. The title says, Bavi crossed Guam after becoming 2026's third Category 5 storm. NASA used that regional description because Bavi crossed the U.S. Northern Mariana Islands and Guam area, and its impact spread across both jurisdictions. But the satellite image tells a more precise story. The eye passed over Rota, and at its closest approach, the center was about 75 miles northwest of Guam. That difference explains why the worst wind on Rota and the damage on Guam were related but not identimage. And Rota entered the eye wall, while Guam remained south of the center, inside powerful outer portions of the circulation. Government updates reported sustained winds around 50 to 80 miles per hour on Guam, with gusts reaching about 100 miles per hour at the international airport. And those winds were far below Bavi's peak near the eye, yet they were strong enough to pull down trees and utility lines, scatter debris, block roads, and complicate emergency movement. At the same time, rain kept falling as forecasts before passage called for many inches across the islands, with the highest totals near the center. By the afternoon of July 6th, observations across the Marianas indicated that roughly 8 to 15 inches had already fallen in places, while trailing bands continued to threaten flash flooding. On Guam, officials reported impassable roads caused by flooding, fallen trees, downlines, rock slides, and the storm was moving away. But the emergency was not over. That is the deeper story behind a Category 5 crossing. And the number describes maximum sustained wind near the cyclone center. It does not describe rainfall totals, storm surge depth, wave height, the width of damaging winds, the vulnerability of power poles, the condition of drainage systems, or the time required to restore drinking water and reopen a harbor. And those consequences are shaped by the storm's structure and by the systems lying in its path. Bavi's center crossed Rota. Its disruption crossed the region. And to understand how a tropical storm became this powerful so quickly, we have to look beneath the cloud tops and inside the rotating core. The visible spiral was the result of a continuous exchange of heat, moisture, and momentum between the warm ocean and the atmosphere above it. And tropical cyclones draw energy from warm seawater. Evaporation transfers moisture into the lower atmosphere, where rising air cools and water vapor condenses. And that condensation releases heat, helping air continue rising and lowering pressure near the center. Air at the surface then accelerates inward, turns because of Earth's rotation, and feeds more thunderstorms around the developing circulation. Warm water is necessary, but it is not sufficient because a storm also needs an atmosphere that allows its thunderstorms to organize around the center. Strong vertical wind shear, meaning a large change in wind speed or direction with height, can tilt the vortex and push thunderstorms away from the low-level circulation. And lower shear makes it easier for the center at different altitudes to align, allowing the storm to build a more symmetric ring of deep convection. Bavi moved over sea surface temperatures near 30 degrees Celsius, or about 86 degrees Fahrenheit, according to satellite observations cited by NASA. And the storm also developed a highly organized structure, and as its thunderstorms wrapped more evenly around the center, pressure fell, winds accelerated, the eye became clearer, and the eye wall tightened. Energy that had been spread through a looser circulation concentrated around the core. And the change was dramatic because rapid intensification is commonly used for a sharp increase in maximum sustained wind over a short period. Bavi's increase was far larger than the minimum threshold typically used by forecasters, and from July 2nd into July 3rd, it gained roughly 100 miles per hour in a little more than a day, according to NASA's visualization based on operational storm data. That rate matters because intensity forecasts remain difficult, especially when a storm's internal structure is changing, and track forecasting asks where the center is likely to move. Intensity forecasting asks how strong the cyclone will become along the way. The two problems interact, but they are not the same. A reasonably accurate track can still lead to a major change in expected impact if the storm becomes much stronger than anticipated. Internal cycles can also interrupt a simple strengthening trend when a new ring of thunderstorms forms outside the original eye wall. Yes, that outer ring contracts. It can weaken the inner eye wall, causing maximum winds to fall temporarily while the wind field expands in what meteorologists call an eye wall replacement cycle. The core was rebuilding. Bavi appears to have gone through such a cycle after reaching its first Category 5 peak. Its maximum winds dipped, then rose again as the storm reorganized. By the night of July 5th, the cyclone had returned to roughly 180 miles per hour, and the center was only about 115 miles east-southeast of Rota. A brief weakening had not removed the threat. It had changed the structure, and that is why forecasters do not treat one intensity number as a permanent label. They watch the eye wall, cloud symmetry, pressure, winds, ocean temperatures, and surrounding atmosphere as a continuously changing system. At Category 5, storm can weaken to Category 4 and return to Category 5. Its strongest winds may contract or expand, while a small shift in track can move the eye wall from open water to an island within hours. The word super typhoon adds another layer of classification, because the National Weather Service defines it in the western North Pacific as a typhoon with maximum sustained winds of at least 130 knots, or about 150 miles per hour. And Category 5 on the Saffir-Simpson hurricane wind scale begins at 157 miles per hour, so Bavi satisfied both descriptions near its peak. Although neither label measures the whole storm, the phrase third Category 5 storm of 2026 also needs a boundary. It is a count of tropical cyclones that reached the Category 5 wind threshold during the calendar year, not a ranking of the third most destructive disaster and not proof that all three storms struck populated land at full strength. And storms may reach their peak over open ocean, weaken before landfall, or produce their worst rainfall after maximum winds decline. And the count is meteorologically important because Category 5 intensity is rare, but human consequences depend on the path that follows. Bavi's path made the number immediate because the cyclone did not reach its peak in a remote part of the basin and then fade harmlessly. It maintained Category 5 strength into the Marianas, with the core crossing Rota while Guam, Tinian, and Saipan remained under warnings. That combination of exceptional intensity and direct island exposure is what turned a seasonal statistic into a regional emergency. And the storm name can also cause confusion across different agencies. In the western North Pacific, systems are tracked by several operational centers, and wind estimates may use different averaging periods. And the National Weather Service products for Guam relied on Joint Typhoon Warning Center info the system identified as Bavi, or 09W. The values used here follow the 1-minute sustained winds communicated in those official local products and in NASA's account. Mixing them casually with 10-minute wind estimates from another agency could create apparent disagreements that are methodological rather than evidence that one center observed a different storm. And that detail matters near category boundaries because a 5-minute or 10-minute average smooths brief peaks more than a 1-minute average, so the same cyclone can carry different numerical maximum winds in separate official records. The physical storm does not change when a reporting convention changes. Editors, broadcasters, and emergency managers have to preserve the measurement system attached to each number. For residents, the warning message was simpler. Bavi was capable of catastrophic wind near its center, and the center was moving toward the islands. And the Saffir-Simpson scale is a wind scale, so it does not include rainfall, storm surge, wave action, or flooding. And that limitation becomes especially important across small islands, where steep terrain, short rivers, exposed coastal roads, power infrastructure, and limited routes can turn different parts of the same cyclone into separate emergencies. Bavi's approach demonstrated that problem in real time because early guidance placed the track near Rota, but all 4 main islands in the southern Marianas remained under typhoon warnings because minor changes could have moved the most destructive core. Officials could not prepare only the island under the forecast line, and the entire region had to act, which also exposed the limits of hindsight. Once the final track is known, the warning area can look overly broad, but before landfall, small shifts remained possible. Guam, Rota, Tinian, and Saipan could not prepare using the final track that only became obvious after passage. They had to act on a forecast cone, an expanding wind field, and the possibility that the eye wall might move. And the cost of broad preparation was disruption, but the cost of preparing too narrowly could have been catastrophic exposure on the wrong island. That asymmetry drives tropical warnings. Guam entered condition of readiness 1, and residents were told to remain indoors. Rota faced an extreme wind warning as the eye wall arrived, with destructive winds above 150 miles per hour. And Tinian and Saipan also experienced severe conditions, while across the coastal waters, forecasts warned of seas reaching about 45 feet near the storm center, conditions capable of endangering vessels and shifting navigation aids. The forecast line was not a wall, and the track line narrowed the highest risk zone, but the storm did not. Bavi attracted attention for another reason, because it followed Super Typhoon Simlaku, which had approached the same island chain in April. And for the second time in roughly 3 months, residents faced an exceptionally powerful tropical cyclone. Repeated storms can compound vulnerability even when their tracks and strongest impacts differ, because repairs, emergency supplies, communications, shelters, and household finances may not have fully recovered before the next warning begins. It would be easy to turn that sequence into a claim that every future storm will follow the same pattern. The evidence does not support that conclusion, because tropical cyclone activity varies from year to year, and one active period does not create a reliable countdown to the next direct strike. And what Bavi does show is how quickly the forecast problem can escalate when a storm forms far enough east to spend additional time over warm water before reaching the western Pacific Islands. And the important mechanism is not a mysterious force pulling storms toward Guam. It is the combination of steering currents, ocean heat, atmospheric moisture, wind shear, and the storm's own internal organization. A ridge of high pressure to Bavi's north helped steer it westward, and the warm ocean supplied energy, while favorable structure allowed the core to consolidate. The result was a cyclone that, strengthened faster than the human systems in its path, could physically move out of the way. Islands cannot evacuate inland for hundreds of miles, so they shelter, secure, close, stage, and wait. That physical reality turns forecast lead time into infrastructure time. And ports must move ships or secure them, utilities must position crews and protect equipment, and hospitals and shelters must prepare for backup power. Residents must decide whether a building can withstand extreme wind or whether official evacuation guidance requires them to relocate. Every hour before damaging winds begins has operational value, and Bavi's rapid intensification compressed that window. The track remained a critical question, but the intensity became the accelerating pressure behind it. And by the time the storm reached the Marianas, the difference between a direct eye wall strike and a passage 75 miles away determined which island faced catastrophic winds and which faced a broader mix of destructive gusts, flooding, and cascading service failures. And that was the midpoint of the event, while the next phase began after the eye moved west. On the morning of July 6th, Bavi's eye wall crossed Rota. National Weather Service updates warned of winds up to 180 miles per hour, with gusts estimated as high as 250 miles per hour near the core. And the eye brought a temporary lull, followed by the return of violent winds from the opposite direction as the backside of the eye wall passed. For anyone inside the eye, that lull can be dangerously misleading. The sky may brighten and winds may fall, but the cyclone has not ended. The second half can arrive rapidly, striking structures already weakened by the first. That is why officials repeatedly instructed residents to remain sheltered. South of the center, Guam endured a different but still damaging profile. Government updates describe sustained winds of 50 to 80 miles per hour, gusts near 100, intense rainfall, flash flooding, fallen trees, downed utility lines, rock slides, and debris. Roads became impassable, and Marine Corps Drive was partially closed while crews cleared hazards. Emergency officials told residents to stay off the roads so responders could work. Water added to the wind damage because before passage, forecasts suggested 8 to 12 inches on Guam and higher totals closer to Rota. During the event, flash flood warnings covered Guam and Rota as radar engages indicated heavy rain and flooding already occurring. By late July 6th, regional observations indicated 8 to 15 inches had fallen in parts of the Marianas, and additional rain remained possible from trailing bands. Along the coast, storm surge, high surf, and enormous seas increased the danger. Earlier local statements warned that surge near the center could reach several feet, while marine forecasts described seas up to 45 feet near Bavi's core. And those numbers did not mean a uniform wall of water around every island. Local shoreline shape, reef structure, wind direction, tide, and the exact center track all influenced coastal impact. And the same storm produced different hazards over short distances, and then came the infrastructure cascade as power failures affected much of Guam and roads were blocked by trees, lines, flooding, and debris. Water production and distribution depended on wells, pumps, treatment systems, electricity, generators, and pressure. When those systems lost power or suffered damage, restoration required more than simply turning the grid back on. And the port faced its own hidden hazards because before Bavi arrived, the Coast Guard closed or restricted maritime traffic as conditions deteriorated. After the storm, crews had to inspect channels and navigation aids before commercial operations could safely resume in Napa Harbor. A buoy had moved off station and ended up in the entrance channel, exactly where vessels expected safe water. The wind had stopped howling, but the channel was still dangerous. And this is the post-storm danger that a satellite image cannot show. A displaced buoy, a damaged VHF tower, a grounded well motor, a broken power connection, or a tree leaning over a road can extend a cyclone's effects long after the clouds move away. And recovery becomes a sequence of inspections and dependencies because a harbor cannot fully reopen until the channel is checked. A well cannot return to service until repairs and water quality tests are complete. A neighborhood may remain dark after the main feeder is energized because local equipment or customer connections are damaged. The percentages of restoration can rise quickly while individual households still wait, and communications were part of that dependency chain because after Bavi, authorities reported major VHF coverage problems because towers on Rota and Saipan were offline with the Rota tower damaged by the storm. Mariners were warned that several navigation aids were missing, displaced, or showing discrepancies. A boat leaving harbor after the sky clears can therefore face a different map from the one it used before landfall. The same principle applies on land because a road may look passable until a damaged pole, unstable, a tree, washed shoulder, or hidden power line turns it into a hazard. Emergency officials repeatedly asked drivers to stay away because extra traffic slowed debris removal and blocked responders. Recovery speed depended not only on the number of crews available, but on whether they could safely reach the next failure. And this is why the days after a tropical cyclone cannot be reduced to a before and after photograph. The visible debris is only the surface layer. Beneath it is a changing network of operating status, safety inspections, temporary generators, water pressure, testing requirements, shelter capacity, and the all clear was not recovery. On July 7th, Guam returned to condition of readiness 4, and the typhoon warning was canceled. Normal operations began to resume, but that official all clear did not mean every service had returned. The port of Guam reopened to unrestricted commercial traffic on July 9th after crews removed the displaced buoy and assessed the waterway. Power restoration continued in phases, and on July 9th, the island-wide system load was reported at 46%. And by July 11th, it had reached 74%. And by July 15th, authorities reported that 99% of the island-wide system load had been restored, while crews continued addressing isolated outages and power quality problems. Water recovery followed a different timeline because wells and booster stations returned as power and repairs allowed. Some customers experienced low pressure or no service, and a precautionary boil water notice applied to customers who had lost water for 48 hours or longer, and crews repaired ground or well motors and collected samples before returning affected wells to service. Shelter and food needs continued after the weather emergency ended. Government releases announced commodity distributions and temporary shelter capacity for residents still displaced. Debris sites accepted green waste and construction material, while damage assessment teams prepared to document impacts to homes and businesses. By July 16th, Guam's Recovery Office announced a residential damage assessment running through July 24th. That ongoing process matters because early descriptions such as extensive damage are not the same as a completed verified total. In counting damaged homes, businesses, public facilities, and infrastructure takes time, and figures may change as inspections reach more locations. The most honest account is therefore specific about what is known. Bavi became a Category 5 storm and reached peak winds near 108 miles per hour. Its center passed across Rota, while Guam lay about 75 miles south of the center at closest approach. Guam still experienced destructive winds, flooding, blocked roads, utility failures, port disruption, and a prolonged recovery. Official damage assessment remained underway more than a week later. Those facts are dramatic without adding an unverified casualty number or pretending every island experienced the same storm. The Category 5 label explains the potential of Bavi's core, and the regional impact explains why distance from the eye did not equal safety. Return now to the nighttime satellite image, where moonlight catches the western edge of the eye wall, while the center appears almost calm. And from orbit, the storm looks complete and self-contained, while on the ground, its consequences spread through a network of roads, poles, wells, ports, radios, shelters, homes, and coastlines. That is where the story becomes larger than the eye. And the strongest winds passed over Rota, but Guam's recovery shows how a near miss by the center can still become a direct hit on essential systems. The difference between those phrases is not wordplay, it is the difference between a storm's meteorological center and its human footprint. As of July 21st, the National Weather Service showed no active tropical cyclone watches, warnings, or advisories for Guam and the Marianas. Bavi was no longer an immediate weather threat to the islands, and power had largely returned on Guam. Ports were operating again, and recovery work had moved from emergency response toward damage documentation and remaining repairs. Yet the storm still leaves three questions for forecasters and island communities. And the first question concerns rapid intensification because Bavi gained extraordinary strength over a short period, and forecasting exactly when that acceleration begins remains one of tropical meteorology's hardest problems. Better observations of the upper ocean storm structure, moisture, and wind shear can improve guidance, but no single measurement guarantees the outcome. The second concerns track precision because a movement of several dozen miles can shift the eye wall from one island to another. Bavi's center crossed Rota, while Guam experienced severe but different conditions to the south. Forecast uncertainty must therefore be communicated as a corridor of possible impacts, not a thin line that divides danger from safety. And the third concerns recovery dependence because electricity, water, transportation, communications, and ports are linked, and restoring one system may require another to function first. Resilience is therefore not only about stronger buildings, it is also about backup power, repair access, spare equipment, protected communications, reliable water testing, debris clearance, and the ability to inspect critical routes quickly after the storm. Preparedness is not a prediction that another Category 5 storm is about to arrive. It is a response to a demonstrated hazard in a region where tropical cyclones occur and where the ocean can support extremely intense storms. And residents should follow current instructions from the National Weather Service, Guam Homeland Security, CNMI emergency authorities, and local officials whenever a new system develops. Bavi also shows why the Saffir-Simpson category must be handled carefully. The lower category does not remove flood or surge danger, and a Category 5 label does not tell every location what wind it will receive. The scale is valuable because it communicates maximum sustained wind near the center. It becomes misleading only when that one number is treated as the complete impact forecast. In the storms, title-worthy fact remains true, because Bavi became the third Category 5 tropical cyclone of 2026. And crossed the Guam Northern Marianas region. But the deeper fact is more useful. The eye crossed Rota, the hazard spread across the island chain, and recovery continued long after the center disappeared over the western horizon. That is what scientists and emergency managers will carry forward, and the lasting record includes not only the peak wind, but also the speed of intensification, the width of the circulation, uncertainty in the track, vulnerability of essential systems, and the time between an all-clear and true recovery. The final image is no longer only a moonlit high over warm water. It is a navigation buoy shifted into a harbor channel, utility crews rebuilding a grid, water technicians testing repaired wells, and residents reporting damage while the sky is already cleared. The storm moved on. Its footprint remained.